Okay, so this video is going to walk you through page 134. And so all I started doing was, at the very bottom of the paper, I started factoring. So it tells you up here that everything in the numerator has a -2 in common and that x plus 4 is a factor. So what I did was I pulled up the -2 and I put -4 in the house and did synthetic division. Get down to x squared minus 9. So that factors into x plus 3 and x minus 3. So now my numerator up top looks like -2, x plus 4, x minus 3, x plus 3. And then the denominator, the other hint right here, says that everything in the denominator has something in common. So I pulled out a 2, and I'm left with x squared plus 5x plus 4, which factors into x plus 1, x plus 4. So now that I'm factored, I can go through and do some stuff. First things first, I'm going to have a hole. And I know my hole is going to be at x equals -4, and then you go back up here and you plug in the -4 for the y stuff. So -2, -7, -1 divided by 2 times -3. So this is going to be a +7 times the -2, which is going to get me -14 over -6. Which is going to reduce down to a +7 over 3. So my hole for this equation is at -4, 7/3. This x plus 1 in the denominator has to be my vertical asymptote, so x equals -1 is my vertical asymptote. This does not have a horizontal asymptote, it's a bottom. If I had a horizontal asymptote, you always want to make sure you answer the question, does it cross? Since I don't have one, I know it doesn't cross it. Then it says find the slant asymptote, so I'm going to go ahead and go down here and do that. Actually, let me get a piece of paper. So if I want to find my slant asymptote, I'm actually just going to divide the numerator by the denominator. I'm actually going to do this long division problem. So how do you make 2x squared look like -2x cubed? Well, you multiply by a -x. -2x cubed minus 10x squared minus 8x. Subtract the whole thing. The first ones cancel out. This becomes a positive, so -8x squared plus a 10x is going to make me be a 2x squared. And this is going to become positive also, so this is going to be 18 plus 8, which is going to get you 26x. And then you have to bring down the 72. And then how do you make 2x squared look like 2x squared? Well, you multiply by a +1 and then you stop. Because anything after this point is going to be the remainder, and I don't care what the remainder is. So this is my slant asymptote. So if I go over to my paper, I have a slant asymptote of y equals -x plus 1. To do the y-intercept, you let x be 0. So if I go up here, 0, 0, 0, 0, 0, 72 divided by 8 is 9. So I have a y-intercept of 0, 9. To find the x-intercepts, you set the whole equation equal to 0. So you put a 0 here, which means you would have to multiply the denominator over, which means you're really just setting the numerator equal to 0. This was a whole, so it can't be an x-intercept. So these two things right here are my two x-intercepts. So I have x-intercepts of 3, 0. And -3, 0. Before I complete the table at the bottom, I'm going to graph what I have. And before I do that, I'm going to write my domain. Remember that your domain, you have to take the x part of the whole into consideration and your vertical asymptotes. And that's how you get your domain. So I'm going to go from -infinity to -4. And I'm going to jump over -4 and go to -1. And then I jump over -1 and go to infinity. So now I'm just going to graph really quick, and the lines are really, really, really faint. Not so great of a copy job. I apologize for that. Okay. So -4, 1, 2, 3, 4, 7/3, which is like 2 1/3, so about right there. Vertical asymptote of x equals -1. Make sure your asymptotes, you draw dotted lines, not solid lines. No horizontal asymptote, slant asymptote. I'm going to start here at 1, and I have a negative slope, so I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, or, oops, sorry, wrong direction. That would have been a positive slope. Down 1 over 1, down 1. So you have a slant asymptote that looks like that. And then you're going to graph your intercept. So I have an intercept of 2, 3, 4, probably all the way up here at 9, 0. 5, 6, 7, 8, 9. And then you have 2 x-intercepts at 1, 2, 3, 0. And -1, 2, 3, 0. Okay, so based on rational functions, this side should probably do something like this. And this side's going to do something like this. But this is where the table comes in handy. So grab your calculator, and you're going to add a new page, or add a new document, and you're going to actually add this rational function. So type -2x raised to the third minus my 8x squared. Please note that I'm always going back when I do the table, and I'm using the original function. Plus 18x over 70, or plus 72 all over 2x squared. Oops. X squared plus 10x plus 8. So there's my function all typed. And that's about what it looks like, but so I'm going to plug some stuff in. So if you press menu, and then number 5 is trace, and then number 1 is graph trace. And so now I can type any point that I want. So looking at my graph, I want to know what happens at -5, so I'm going to type -5, and press enter. And it tells me down here in the corner, -5, 4. So in my table, I'm going to add -5, 4, and I'm going to plot -5, 4. And let's see, I want to know what happens at -2. So -2, -2 is -5, -2, 1, 2, 3, 4, 5. So now I can see this side of the graph. So there's this side, and no, I'm not an artist, so it's okay. Please forgive my drawing. Okay, on this side, let's see. I want to know what happens at, let's say, 0, which I know is actually 9 up here. So let's try 1. 1 is at 4, so 1, 1, 2, 3, 4. Let's try 2. 2, I'm at 1.67, so 2, almost a 2. I know what happens at 3, let's try 4. At 4, you're at -1.4, so like right there. And now I can see this side of my graph taking shape. There we go. And so now I have everything filled out, including my table at the bottom. And I have my points, and there's my graph. Hope that you got the same answer that I did.